students, good evening. Today we are going to study about the chapter 6 of class 8, that is combustion and flame. The topics to be covered in this lesson are introduction, what is combustion, combustible and non-combustible substances, ignition temperature, fire, fire control, types of combustion, flame, structure of a flame, fuels and efficiency, and last, that is concerns with burning of fossil fuels. So students, have you seen a candle burning or have you ever ignited a matchstick? You must have used the Bunsen burner in your chemistry laboratory to heat the substances or chemicals inside the test tube. Your gas burner inside your kitchen, which is used for cooking a lot of things. When you try to burn a log of wood or charcoal or coal, so what happens when you burn these substances? What do you see when a candle is burning? What do you see? We see the fire, right? So we see this flame of the candle. We can see that it is visible. Similarly, when the Bunsen burner is on, we can see the flame again. When you burn wood, you can actually see the fire which is being produced. The gas burner, when switched on, again what do you see? You see flames. Now, if you look at all of these flames and fires, they all look very different from each other. Do you think the flame of the candle and the flame out of your gas burner, they look similar? No, even their color is different, their appearance is different. So now in this lesson, we are going to discuss all about burning. How this phenomenon or how this process of burning takes place. Now, what we call as burning in common terms is what is known as combustion in science. So in combustion, we will see what is this exact process, how does it produce fire, is it that all substances can give rise to fires and flames? So we are going to discuss all about that. So let us start with what is combustion. It is a process in which a substance reacts with oxygen to release heat and light, and that is what we actually see as flame or fire in different substances. Now what happens when you light a candle? You see the fire, right? So because of that fire, even if you try to light a candle in a dark room, what happens? When the candle is lit, the fire actually gives light to the entire room. So it actually releases light, and at the same time, if you try to take your finger near the flame of the candle, you feel hot. Why? Because heat is also released during the process of combustion. So you can think combustion as the process of burning. But how do we define this process scientifically? Because what exactly is happening inside that, so much of heat and light is being produced. Now basically all that is happening is the substance is reacting with oxygen. This is very crucial. Combustion can take these only when oxygen is present in the surroundings. If there is no oxygen, there will be no combustion, there will be no burning. So this is basically combustion. Now when you talk about a release of heat and light, now it is not necessary that light has to be released during combustion of all the substances. Light may be released, light may not be released. Now if light is released, the light can be released in the form of a flame. Light can be released in the form of glow. For example, if you try to compare the process of combustion in candle and coal, so here you see coal and here you see candle. Now in both the cases, if you burn both of them, so what I am trying to explain is, if I burn both of these, the process that is taking in this combustion, because as soon as I burn it, the substance that is the coal or the wax of the candle, it is reacting with oxygen of the surroundings, and due to that reaction, a lot of heat and a lot of light has been produced. Now if you compare these two scenarios, in this scenario you see you really do not get a fire or you really do not see a flame in case of coal. But what do you see? You can see a reddish glow on the coal. That happens due to combustion. Whereas in case of candle, you can very distinctly see the presence of this flame. Now that's so it depends how light gets emitted in different substances. It depends from one substance to another. Now again, it is not also important that all the substances will burn to release heat. So we can say that not all substances undergo combustion. You take example of matchstick. So do you think that matchstick undergoes combustion? Yes, it does. Now, why I took this example? Well, since I was talking about substances which do not undergo combustion, so that is just to confuse you. But yes, matchsticks undergo combustion, because you see what do you actually need to do so that the matchstick catches fire? All you need to do is you have to rub it, or you have to strike it against the side of the matchbox. So when you strike it, there is friction. When it's friction, there is heat and the matchstick ignites. Now once it ignites, you can see the flame. So light is released, heat is also released, and you can feel that if you take your finger near the matchstick or burning. So that is matchstick undergoes combustion. Now let us look at some examples of combustible substances. Now what are combustible substances? Those substances which undergo combustion, that is, they burn easily to release heat and light. Sometimes light, so that not all substances can undergo, or not all substances can burn to release heat. So those substances which can burn to release heat, they are called combustible substances. And examples are all these which you see on the screen. For example, paper. So if you see paper, do you think that paper burns easily? So just being a matchstick near the paper, and you see that immediately it catches fire. So paper is combustible. You take example of a matchstick, again it is combustible. It easily catches fire. You take example of a diesel, petrol, kerosene. So you take all these examples, and just using that, they very easily catch fire. That is why you would have seen that in the petrol pumps and people are not allowed to smoke. Why? Because the chances are very high that if in case of somebody leaves a burning cigarette or a matchstick there, so the chances of petrol catching fire is very high. So that's why it is not allowed. You take examples. Most of the metals, such as if you take example of iron or any metal, such they are non-combustible. They do not undergo burn. They do not burn to release heat. But some metals in their powdered form, for example, aluminum powder or magnesium powder. So all these powdered form of metals, they are combustible. That is, they get burned to release heat. So these are all examples of combustible substances. Of course, wood, coal, they are also combustible substances. Now, it is just that all these combustible substances, they undergo the process of combustion in different ways. Some of them will produce huge fire, some of them will produce flame, some of them will just show some sort of glow. So that varies from substance to substance. On the other hand, we have a set of non-combustible substances which do not undergo combustion to release energy. So they will not get burned to release energy. Let us look at some examples. Most of the metals are non-combustible. So if you take a piece of iron, just take an iron for example, you take either nail. So if you take this nail and put it even fire, do you see that the nail burns? Nothing happens to the nail. The metal does not readily burns, so it doesn't burn easily. So that is why it is non-combustible. So you take another example, glass. Glasses also do not burn. Take examples of steel. So steel also contain a metal. So steel also doesn't burn. You take examples of stones, rocks, so they are all examples of non-combustible substances. You think of any of these substances and you will be able to find that they do not burn easily to release heat. So that is why they are categorized